are several types of chemical bonds that we can discuss, but in this video I'm just going to focus on the metallic bond. The metallic bond is, as the name implies, found in metals or in metallic elements. In this video I'm going to focus on the definition of the metallic bond and the model of the metallic bond, and also the influence on the properties of metals. Now, let us start with the definition. When it comes to definitions, I always want you to follow what your syllabus is saying, but I'm just going to give a brief description of how you would define metallic bonding. So the definition of a metallic bond, definition of metallic bonding. So this is I'm just going to give the essential parts of that definition. One, it is the bonding in metals or in metallic elements, in metals, whereby positive metal ions, are bound together, by I'm going to call it a sea of delocalized electrons, Please get me right. The definition that you're going to use, it depends on your syllabus. So you should check your syllabus and see how they are defining the metallic bond. But I'm just giving you a brief approach to this definition because one, it occurs in metals, and here the positive metal ions are bound by a sea of delocalized electrons. This is the definition of metallic bonding. It is a chemical bond, and it occurs in metals, and in this bonding we have metal ions, which are positive, by the way. They're being bound by a sea of delocalized electrons. We can best describe this with a model. So let us go to our model for metallic bonding. This is the model that we're going to rely on. If you look here, these positive guys here are the metal ions. These are the metal ions. In other words, these were metal atoms that sort of lost, or they gave up, their valence electrons. The valence electrons have been given up. They are not donated elsewhere. They just form this pool. They're called delocalized because they're not stationary. They're not on one point. They're actually free to move. So this is all this negative charge that you see in this diagram. All this negative charge here, these are electrons. So these are electrons. The electrons in this model are delocalized. They are not fixed on one position. They are free to move. So these are free electrons. We actually call them free electrons. These are free electrons. They're free to move. They don't belong to one place, or they don't belong to one of these metal ions or metal atoms, by the way. They don't belong there. They are free to move. That is what we mean by delocalized. Now, what keeps these together is the fact that there is electrostatic attraction here. We have positive charge here and negative charge here. And we know from our physics that if opposite charges attract, so this sea of delocalized electrons acts as a glue that keeps the positive metal ions together. So this is where the bonding is coming from here. It is coming from the electrostatic attraction between the metal ions and the delocalized, or the free electrons. How do they become to be ions? I say and I repeat, they became ions because they gave up their valence electrons. So the valence electrons in these metal ions, in these metal atoms, are actually given up, leaving the metal atoms as positive ions. This is what we mean here. So these are positive metal ions, and these valence electrons, they now go into sort of like a pool of electrons, which we are referring to here as a sea of delocalized electrons. Very, very important. So this is the model of the metallic bond. This is the model of the metallic bond. If someone says to you, draw a model of the metallic bond, you draw something like this and you label that these are positive metal ions, and around them there is a sea, so that they're sort of like swimming in this sea of delocalized electrons. Now, from the model, I just want to go to how does this model of the metallic bond influence the properties of metals themselves. We have to go there. So let us put this off. Let us come here. Now, we know the properties of metals, and they have to be explained, or they can be explained in terms of the metallic bond. The first property that I want to talk about is the high melting point and the high boiling point of metals. Almost all metals have got very high boiling points and very high melting points. The reason for this is that the metallic bond itself is actually a very strong bond. As we said, this is electrostatic attraction. So the electrostatic force of attraction between the positive metal ions and this sea of electrons, that force is actually a very strong force, giving rise to a high melting point and a high boiling point for metals. Very key, very important that you know how to explain this property in terms of the metallic bonding. Now, we also know that metals have got very high thermal conductivities and very high electrical conductivities. In other words, metals are good conductors of heat. Metals are good conductors of electricity. Why? Because these delocalized electrons are free to move, and they transfer heat or electricity from one point to another. So the high thermal conductivity and the high electrical conductivity of metals can be explained in terms of the ability of these delocalized electrons to transfer the heat from one point to another, or to transfer electricity from one point to another. That's it. Then we also know that metals are malleable and ductile. In other words, metals can be hammered into shapes. You can take a hammer and you beat a metal into a different shape that you want. They are also ductile, which means they can be pulled into wires. If you bring a block of metal, whether it's copper, from there you can actually make wires from copper. Why? Because the metal ions, they can easily slide. They can easily slide around. As you can see from our model, let me come back to the model. Let me come here to the model. As you can see from the model here, these positive metal ions, they can actually slide. So if you take a hammer and you hit here, they can slide, and thereby making the metals ductile. In the same manner, you can actually pull the metal into wires, which we speak of as ductility. Malleability and ductility are actually due to the fact that these metal ions can actually slide or move if hammered or if pushed. They can actually move, slide over these electrons and form new shapes. This is what we mean. We can explain that in terms of the metallic bond. Otherwise, that's it. This is what you should know about the metallic bond. And I want to emphasize that you should be able to explain the properties of metals using the metallic bond, or using the model of the metallic bond. Thank you for watching the video. If you have any comments or any queries, just write in the comment section below. Otherwise, give a thumbs up to the video and share with your friends. Don't forget to subscribe to the channel.